Good evening. My name is Andrew Dodd, and a very warm welcome to today's webinar. Apologies that we didn't get any sound with the holding slides. It's entirely my fault. Pressed the wrong button on the Zoom call, so I apologise for that. I'll just talk for a moment, just to let everybody catch up. I know we've got a lot of people wishing to join tonight's webinar, and we'll just let everybody join in. And I'll just carry on talking for the moment. What we're going to do shortly, we'll be starting the event. I'm just watching the count on participants. It's still going up, so we'll just hold a moment. I'll carry on talking about this. We will start very, very shortly, and with tonight's webinar. Okay, well, we'll assume everybody's caught up. What we're going to try tonight is something slightly different in terms of the questions and answers. There is a Q&A page, and there is an option set up where you can vote for existing questions that have been asked by somebody else. So please use that facility because it will help us. We're expecting and already have nearly 400 participants on tonight's webinar. And obviously we're not going to get through 400 questions. We will collate the questions and Vance will answer them separately, and that will be posted on the IET Bucks website. But if you can vote for your most popular question, and then Vance will answer them tonight. The webinar is being recorded, so if you join or only just now joined and you think you missed something, then it will be recorded, and that also will be put on the IET Bucks website. And the best way of finding that actually is just to Google IET Bucks or Bucks events, and it will take you through to our home page. And I just find Google is often a lot easier to find these things with. Okay, well, once again, my name's Andrew Dodd. I'm a member of the IET Bucks committee. We regularly organise events. In fact, if you are interested in helping your local committee, if you live in the Buckinghamshire area, please drop a line. My email address is actually on the IET Bucks website, and we're very happy if you'd like to help. The main activity is organising events like this. It's not difficult. The main thing is to come with ideas and ideas about talks. So maybe there's some special interest to you, or you've got a contacts in your particular company, people who can talk about a subject. We'd be delighted to hear from you. We don't specify what subject is. I rather would like a nice eclectic range of subjects during the year. So if you have something you'd like to hear about, or know that somebody who could talk about something, then please drop a line to me. I am particularly interested if anybody has any contacts in Formula E, electric car racing. I've been trying to get hold of somebody to talk about Formula E cars. So if you happen to be involved in that or know somebody is, I'd be absolutely delighted to hear from you. The IET is running a survey for the whole of this year and trying to look at better understanding what are the characteristics of IET community's audience, and you and I are all part of the IET community, and to find out how well they're being represented. At the present moment, there is not enough data to understand where improvements need to be made. So there is a survey which is going to remain open through 2021. I will put the web address up on the sidebar, and if you wish to send your response and fill in the survey, we would be delighted to hear from you. Just quickly looking forward before Vance presents his talk. On Thursday, we have a talk which is linked to tonight's webinar. It's a presentation by Keegan Neve, and that's looking at the use of some of the technology Vance is going to be talking about, its use in robot wars. and how you can apply it to a complex robot. Now, Keegan's particularly going to be talking about how you make a complex battle robot from consumer technology. And he particularly is basing it around the Raspberry Pi, which is a very common microcomputer, as I'm sure you're well aware. So if you want to sort of have a talk that's sort of interlinked to today's talk, please join us on Thursday. There are still spaces available if you wish to join that webinar. So that's this Thursday, same time, 7:30. And also, just looking forward into May, on the 12th of May, we're going to have a talk by Phil Gould, who will be looking at an appreciation of amateur radio. As Phil says, this is a hobby which puts together science and technology. And his talk will cover what amateur radio is and how it is used to make friends around the world. And he particularly is going to look at how amateur satellites are used to send communication around the world, which is slightly different from the normal shortwave and other similar areas of amateur radio. And in particular, they can talk to the International Space Station. Okay, without any further ado, I'd like to hand over to Vance Briggs, who will be giving tonight's talk. Over to you, Vance.
Oh, hello, everybody. Can I just check you can hear me before I waffle on too much? Andrew,
can you? Fine.
Yeah, yes, okay, you're good. Fine, yeah.
Okay, so welcome, everybody. I am Vance Briggs. I was in the Air Force for 21 years as initially an apprentice and then an engineering officer. When I left the Air Force, I joined a software company called Autonomy and later worked for Hewlett-Packard. I'm not going to talk anything related to work. This is here to talk about hobby electronics. So I'm going to share my screen with you and then we can work our way through. Okay, so you may have seen from my t-shirt, I'm actually a member of our lab, which is Reading's Hackspace. The Hackspace is a group of interested makers from heavy engineering through electronics, through design, who share a passion for basically making things. We as a group contribute towards the upkeep of our lab, and we rent a small industrial unit in Reading, beg, borrow, and not quite steal tools, and basically run it as a community workshop. So that's how I ended up talking to you guys. I was approached through the Hackspace. So again, it's good to mention it. I believe that there is a Hackspace in Milton Keynes too, although I'm not familiar with the people there. But if you are interested in Hackspaces, if you're in the Reading area, please feel free to contact us. Or again, you could try Milton Keynes. They are also spread across the UK if you're slightly further afield. Okay, I'm going to mention a few open source pieces of software, less on the hardware, but I'm very keen on open source. I'm a hobbyist. Cheap is good and free is even better. But the real benefit of open source is it encourages learning and information sharing. So pretty much all of the tools I've used in the projects and things I'm going to mention tonight use open source. Although one or two are just free as in beer, and I will highlight those just so you're aware. So this is where my hobby electronics started. One Christmas I was probably 9 or 10, and this led me into my career in electrical engineering. I'm now retired, and it's becoming my hobby again. But significantly, the technology's changed, believe it or not. I'm just going to talk mainly tonight about a couple of modern boards here. Obviously, when I was growing up, electronics was mainly analog. We were just about getting microprocessors. But now it's pretty much almost exclusively digital. Around 10 years ago, these boards started to come onto the market, and they've continued to evolve and become more powerful. I'm sure most of you are aware, but the Raspberry Pi is based on a system on a chip which developed for the mobile phone market. And the Arduino uses microcontrollers designed for smart devices. Again, I'm not going to go into massive amounts of depth on the capabilities of these, but I will just, hang on, down one more, just talk briefly about the capabilities. So, as I said, the Raspberry Pi was a system on a chip. In the form of the Raspberry Pi, it runs a full operating system. It runs Linux generally. But it does have electrical interfaces to allow it to connect up to digital electronics. The main ones being general purpose I/O, GPIO, which is just a digital output in most cases, or an input. I2C and SPI are two electrical protocols used to communicate between electronic devices, generally on a circuit board. So the Raspberry Pi has the capability to interface to other electronics, and as Andrew mentioned at the beginning, Keegan's chat on Thursday will cover the use of the Raspberry Pi in a robot type application, and he'll be using these interfaces quite a lot, I would imagine. The Arduino is a microcontroller, and again, just to clarify, a microcontroller effectively is a microprocessor, but it is designed to specifically interface with lots of other electronics, and the microcontrollers tend to have less memory, less processor power and things like that, although that's changing. But they don't tend to run an operating system. So when you're working with a microcontroller, you are in charge of all of the code that runs on that device. Obviously, you may use libraries created by other people, but you create the executable code which runs on there purely. And because they're focused at interfacing with other electronics, the interfaces are a little bit more robust than the Raspberry Pi. The Raspberry Pi runs at 3.3 volts and won't accept. Well, you put 5 volts into it, it's not going to work for very long. The Arduino is 5 volt tolerant, and other microcontrollers, you can get different interfaces. So those were the two starters that really kicked off easy access to digital electronics. But since they started, the hobby electronics market has really kicked off. And you will certainly find a lot of clones. I mentioned open source at the beginning, and the Arduino, when they started building their board, they published their design as an open source design. And lots of other companies have now copied that design and are producing clones, or in some cases using the design as a starting point for building something more powerful or slightly different. These companies, again, I'm not really advertising any in particular, but they are major players who have produced a lot of clones. Adafruit in particular is a good company from not only do they produce the equipment, but they've really focused on education and providing lots of good resources to allow you to get into and understand how to work with their devices. The others are also fairly large players and do provide different boards. So if you have a very specific requirement, you might find that one of these companies will produce a dev board which is closer to your requirements. As I said, Adafruit here this is the actual schematic for their copy of I think it's a feather board. So it's like the Arduino, but it's a different form factor. And again, it's very useful because, the fact it's open source, I can come here, and if it down in the bottom left-hand corner is their LiPo charging circuit. As a hobbyist, it's sometimes quite difficult to know where to start. I need to charge a battery. How am I going to do this? I learn a lot by example, and being able to go and find a schematic of a working board. It first of all gives me the part number, and it gives me a good reference layout that I can use if I want to use that on a separate board. So the open source nature of these is really quite handy. Other things you may have heard of, the Internet of Things, certainly buzzwords around. The key thing about the Internet of Things is connectivity and communications. Here are just a handful of radio protocols which Internet of Things devices tend to use. I mean, you'll probably be very familiar with Wi-Fi. In fact, Bluetooth is an omission on there. As I only picked up a handful of protocols, but Bluetooth is also a protocol you could use for an Internet of Things device. The other protocols here, there's pros and cons for each. And basically, you're trading off data throughput against power, pretty much. LoRa, I'll just call out, is a long-range radio protocol. So this is a low, I hate to use the word frequency, I don't mean frequency. It transmits intermittently, periodically, but at long periods. You've got a very, very low bit rate that you're allowed to average on that protocol, but it's still a good application, or good for certain applications, and particularly it's low power. Zigbee, there are quite a few packages built on top of Zigbee, one of which is Zigbee Home Automation. So again, if you're into home automation, that may be an area that's of interest. And then just touching on Thread, which is quite a new protocol, that promises IPv6 routing over these mesh type networks, which could be an interesting capability depending on, again, the application that you might be interested in. I mean, this is a very complex area, and to be honest, in hobby electronics you might not get this far, but it's good to know that these things are around and you might be able to borrow a design or at least hook up to something that provides these capabilities. This is my favorite for home automation. It's an ESP32. It was originally designed as a Wi-Fi coprocessor, so to hook up to an existing microcontroller. But it's got 2 cores in it, and the hobby market have really taken to it and have produced development tools which allow you to program this thing directly. So this can be your microcontroller and connect through Wi-Fi all in one go. On the left is this called the stamp. It's basically something you could solder down to a circuit board, but if you look on the right, the dev board has already done that for you, and they've put it in a breadboard format where you could just plug that into your breadboard and hook up. So again, quite a nice development board. These boards are very, very cheap. That dev board you would be able to pick up for under £8, and it's got a USB interface for you to hook up to your computer, and you can start to explore and program the board from there. Okay, so if you do buy one, how are you going to program it? There are a number of programming languages, everything from a drag and drop interface across on the left there. Admittedly, they're more focused at the educational sector, but there's no reason, if you're not a coder and you want somewhere easy and basic to start, there's no reason that you can't actually put your application together using that capability. Although traditionally C is the programming language which is used to interface to hardware, for a number of reasons. It's very, very, the syntax is very close to the hardware and how the hardware processes things, which means that you've got sort of a fast and efficient translation between the C code and what's going on in the microcontroller. Although C can be a bit of a nightmare sometimes, and certainly you need to be very, very careful about memory management and other things if you're going to program in C. And again, in the hobbyist market, Python or CircuitPython and MicroPython particularly are starting to make a bit of an inroad, because they take away a lot of the pain. If you're familiar with the desktop version of Python and you've done some programming in that, you'll take to it very easily. But if you haven't, it's still a nice, simple programming language. And what they've done with Circuit and MicroPython is extended the language so that it can work against the hardware interfaces of the microcontrollers. This has really only become possible more recently, when effectively the computing power of microcontrollers has increased. What you're gaining with the simplicity and the memory management is costing you, obviously, in terms of processing power and memory for your program. But for the hobby market, it's definitely worth a look. I'll only briefly touch on IDEs, integrated development environments. Once you've decided how you're programming, your solution, you need to. Well, it's good to have an integrated development environment where you can write the code, upload it to the device, and see any responses. I've pulled up the Arduino IDE because it was the first one that went along with the Arduino, and it did make it very easy for people to get into programming. It's still available, and it's also had a lot of other microcontrollers ported, so you can program well, almost any of the microcontrollers, including ARM-based microcontrollers, using Arduino. Although you may choose to use something else if you get a bit more serious. Again, I tend to use Visual Studio Code, just really because it's a nice environment in which to work. But there are chip manufacturers' IDEs, and as I said, browser-based environments with sort of drag and drop code upload for certain devices. Debugging is a bit of a bugbear, if you excuse the pun there. It is possible on certainly some of the more modern devices to actually do hardware debugging, where you stop the processor and you can look at registers and memory addresses and all that sort of thing. But I say most will probably tend to try and print something out when something happens, and you're trying to follow a trace of what did it last do before it stopped type debugging. But it is possible, as I say, on some of the more complex things, to be able to get in and actually stop the processor and examine the hardware itself. Okay, so you've got your dev board and you've created your first program and everything's working fine. So now what? What do you do next? Well, where I went next, I created my own PCB. That seemed pretty daunting when I started. It now doesn't seem quite so daunting for me, but I'm sure if you're coming at this from the outside, it's a fairly. But first piece of open source software that I'm talking about here is KiCad or KiCad, and it's a great piece of software. It allows you to capture the electrical schematic, how you want your circuit laid out. We saw one of those from Adafruit earlier. You can borrow designs from Adafruit and put them into your own one here. And then it takes that electrical design and allows you to transfer that into design into your printed circuit board. And hopefully what you end up with is something that looks like that on the right hand side there, where you could basically output a bunch of files which you can send away to a board house and have developed. And in fact, there's the one that I designed from there. These boards, to get them made, is absolutely ridiculously cheap. You could get, this board is about 10 centimeters square. And I kept it deliberately 10 centimeters square because that's a price cutoff limit on the board house that I was using. But 10 centimeters square, 10 boards, $5. It costs you more to ship them and probably pay the VAT when they arrive in the UK, depending on how the government managed to catch you at that point. So the actual manufacture of these boards is ridiculously cheap. Obviously, there are surface mount components on here that I've the way I've designed this board, but with some fairly basic equipment, you can populate a surface mount board without too much trouble. But you can also design through-hole boards with through-hole components. If that's probably a reasonable place to start. Again, you buy 10 boards for $5, you've got 9 boards that you don't know quite what to do with. So you can always frame them and put them on your wall, as I did. So it can also lead you into 3D design. Again, I'm mentioning 2 software packages here. Autodesk Fusion 360 is a commercial package. It's not open source, but they've been friendly enough to provide a makers or hobbyists access for free. They're starting to restrict the tools within Fusion 360 that you've now got access to, but there's still plenty in there to be doing a decent 3D design. And the 3D design on the right there is an ant-weight fighting robot, and I'll show you a little bit of that later on. Because Autodesk are starting to reduce the capabilities that hobbyists are having access to, I'm looking at alternatives, and FreeCAD is an open source alternative. A little bit rough around the edges at the moment, but it is receiving a lot of interest, and that's what happened with KiCad about 4 or 5 years ago. The open source community started to get behind it, and it's become, I would say, industry leading capability. And I think FreeCAD will probably be heading in that direction. So one to watch. The biggest benefit of 3D printing from an electronics hobbyist point of view is you can make custom enclosures. But when I started doing hobby electronics, I was scanning the RS catalogue looking for a box that would roughly take the size of the PCB and this, that, and the other that I needed to put in there. With access to 3D printing, I can build a custom enclosure as I have here. And this was one of my projects, which was well, it's a clock. I'll show you it later. But it's allowed me to create what is effectively quite a nice item that would have been impossible before 3D printing. So going on to the projects, as I said, here is the clock. It has my favorite Wi-Fi processor in it. Why do you need Wi-Fi, you say? Well, you've got to get the time from somewhere. So I decided to use the ESP32 as both a method of getting NTP time and also driving the LEDs, which would display the time. I'll fire up the camera at the end, and I'll try and show you this clock live, and we can have a bit of a delve into it. And again, I mentioned the ant-weight fighting robot. You see the 3D design, and here's a photo of the completed project. And again, I used a custom PCB design here and used it as the chassis for the ant-weight fighting robot. So again, it's really useful to be able to create a PCB of a particular shape and put the holes in it you want to be able to bolt things to it. So there we go. So we've got reasonably technical here, and I hope I've not lost too many people. I'm just going to touch briefly on what I think elements of the future are going to be regarding hobby electronics. But at the moment, I think these are going to be at quite the technical end of things. But I want to highlight them because they're becoming available. Field programmable gate arrays, FPGAs. They are a way of creating programmable hardware, basically. So rather than a microprocessor working stuff out, you program the logic to work stuff out in a clock cycle or in a series of clock cycles. It basically means they can be very, very fast. Up until now, FPGAs have been well out of the reach, really, of the hobbyists, primarily because of cost, and also each chip manufacturer had their own nuances, and access to the ability to try and program these things was pretty difficult. But there has been a push again in the open source community to make them accessible with open source tool chains, and Lattice. There are a number of chips from Lattice being enabled through open source FPGA toolchains. So this provides access to very fast and complex electronics. As I say, it's going to be quite niche. Not every hobbyist is going to be interested in this, but it's interesting to see access being made available at this level. And then off the back of that is RISC-V. RISC-V is an open source instruction set architecture. What that means is it's a definition for the instructions of a microprocessor, but what they don't do is they don't tell you how to build the microprocessor. They just tell you effectively the assembly language instruction and how it should, the answer it should produce effectively. Because this is open source, lots of manufacturers are looking at this because it gets them out of having to license processor cores. ARM in the UK are a massive, I don't know what, they're not a manufacturer. They own the IP that's in lots and lots of microcontrollers, microprocessors, and even processors now. But anybody that builds a processor using their core has to pay royalties. So RISC-V is a push to try and open that capability out. And an interesting thing that links back to the FPGAs is that there are open source definitions of how to create a RISC-V processor that run on an FPGA. So you can have a soft processor running alongside your hardware if you need it. Okay. Any question? Before we go to the questions, can I just actually now swap back to my camera, and I just want to show you a couple of bits around those projects. Okay. So here is my clock project. You can see it lit now. If I disassemble my, there we go. So we're now looking directly at the board in situ. Once I've taken the diffuser out. And again, it's just nice to be able to build an enclosure that is as flexible as that. So quite handy. While I leave you looking roughly in that direction, I'm also going to try and fire up the Antweight robot. Excuse me while I just going to put the lid back on, otherwise we'll have the battery all over the place. Okay, right. Okay.
Welcome to OpenTX.
Okay, so here we are. We have contact. I've had to slow it down a little because I'm working on my desk here. And if I don't slow it down, I'm going to find myself speared or the thing bouncing off the floor. But just try and get the, there we go, the flipper working. And again, you can play around with the lights. Just a bit of fun. But these ant-weight fighting robots, there's basically competitions around the UK where you can basically do a bit of mini robot wars yourself. I built that for it's probably, I don't know, 50 to 60 pounds. And it allows you to basically go in an arena with other robots of a similar size and battle it out and see who wins. But I will warn you, there are some fairly professional, seasoned players out there. So it's always interesting to go and have a look. I would suggest you look first. Okay, let's stop there. Andrew, if you want to take over for a minute.
Yes, okay, thanks very much indeed, Vance. In fact, with your demonstration there, which is always nice to see live demonstrations, and at least it didn't disappear off your desk. Actually joining us on the call is Keegan Neve, who will be giving the talk on Thursday, and he'll be talking about applications of this sort of technology in fighting robots. And in fact, I'm trying to think, the robot you've just shown us reminds me of something that was in the last Robot Wars that was on the television. I can't remember which one, but it's certainly a robot very much like that. So Keegan, if you'd like to just join us for a moment and just tell us what we can look forward to in your talk on Thursday, and then we'll pick up on the Q&As for Vance. So Keegan,
sure thing. Oh, just actually try and get some light on me. Yeah, so it might be Apollo that you were thinking of. That was the champion, the winning robot for the last UK edition, at least. I've got a few friends who are actually in Robot Wars and BattleBots, so yeah. But unlike Vance, like Vance said, you know, they're prone to being destroyed. So unless you can live with that, don't join those competitions. So the talk I'm giving is actually going to be on Pi Wars, which is a non-destructive robotics competition. This is my entry, McFeagle Prime. So it's showing this off in more detail, but it's currently asleep. It's based around a Raspberry Pi and an Arduino clone, one of the teensies, one of many that Vance alluded to. And yes, it'll be talking around how I kind of developed the idea for this robot, where I've got to and where I'm going next. Just one thing to mention about one of Vance's early slides, he mentioned SparkFun and Zigbee. Just to put it into context how far these technologies have gone, Mars. So the Ingenuity robot, the helicopter which actually had its first powered flight yesterday, it actually has its altitude sensor, a downward-facing laser distance sensor, was purchased from SparkFun, and the radio protocol they're using is Zigbee. So they've gone full commercial commercial off-the-shelf stuff, and yeah, it's NASA certified. So yeah, I'll carry on. I can carry on talking until people tell me to stop. So okay. Yeah, I'll leave it for there.
All right. Well, thanks very much indeed, Keegan. We'll look forward to your webinar on Thursday. And maybe NASA certified or not, we'll wait and see. But I certainly have a work colleague of mine who took part in Robots War. In fact, he made a very successful walking robot. But I remember him saying that some people were very keen on robots, but not electrical engineers, didn't work out the amount of current a stalled 1 horsepower motor takes. And he said one of the biggest problems at the time he was taking part was people putting in sort of 10 amp cable, and then with a stall current of 80 amps or more, unsurprisingly their cables were burning out. So but he was an electrical engineer, and he did the sums, and it's not difficult to do, but it was surprising that some of the sort of basic things, have you got big enough cables, was missed. Anyway, that's for Thursday. Okay, what I'll try to do, Vance, is pick out from the questions and answers. We've had 26 questions. Some are on slightly I won't say obscure, but sort of very highly technical matters. But I'll do my best to pick up on the ones that seem relevant. But all the questions will be transcribed, and we will send them to you and see what you can answer, and then we'll post the answers. Okay. Just in your talk, I was quite interested. You mentioned 3D printing and using Fusion 360. I had a Fusion 360 was recommended to me, and last weekend I was actually just designing something really stupidly small, putting it into a 3D printer yesterday, and I found actually Fusion 360 was a very nice little product to use. It seems very intuitive. And I could easily find what I wanted to do. So I like Fusion 360 at the moment, and certainly it was very easy to export it into STL and then put it into the 3D printer. Okay, well let's have a quick look at the questions. All right, okay. Now somebody's asked a question about long distance communications between Arduinos. They've said over twisted pair because the radio protocol was relatively short distance. Is that right?
So LoRa's line of sight capability can be in the kilometers. So, but that's ideal conditions. Mm-hmm. But I would expect 1 or 2 kilometers.
Right.
As a working capability for LoRa. But again, it depends on, it obviously depends on the environment. I mean, really good line of sight, because, obviously, as you said, we can all do the maths. I'm a comms engineer, but line of sight gives you a massive improvement.
Well, I'd regard a kilometre as not too bad. I think they were comparing it with, is it I2C? Which is not something I know anything about, but they just said this is Adam just saying I2C has a very limited range.
Oh, absolutely. Sorry, I2C. So I2C is really an on-circuit board protocol. It's an electrical protocol, not a radio protocol. Whereas LoRa is a radio protocol.
Okay.
And I think you mentioned twisted pair.
Yeah.
If you wanted to separate a couple of things by distance, you could use RS-232, RS-485. Generally, it's just supported by these microcontrollers.
Yes. Yeah. Okay. Lovely. Thank you. Well, I'm a keen fan of twisted pair myself, not necessarily in this application, but that's my background is in such things as twisted pair, so I sort of understand that inherently. An anonymous questioner has said, if they develop a project, say using ESP32, using open source libraries, are they allowed to sell it commercially?
Yes, as long as you're not breaking any of the licensing. So I think the ESP32 is not, you buy them and you own them, you don't have to license them. And as long as you've used open source libraries and therefore you're not breaking any of the licensing issues, yes, you should be able to sell them. Again, there may be some restrictions on the open source license. You may need to supply source code with your item if you're selling it. And again, you need to be careful about which licenses, what the requirements are of each of the licenses. But that yes, you can certainly sell it.
Okay. Brian asked the question, where can he find a technical specification for, and he says, for example, the Arduino. Typing online, he's not found anything yet to give even the most basic specification on things such as the power requirements. And he says, can it be powered from USB or interfaces?
Either or both. Well, not both at the same time. Typically, the Arduino is powered from the USB, typically. Certainly when you're programming it, that's how you work. Now, if you hook it up to something like motors and other things, you might not want to power it from the USB. If I go back, just...
If I'm right in thinking, you use GPIO interfaces, wouldn't you? And you can separate out the voltage, can you?
There are power pins on the side, so you don't have to use the USB. You could hook up to the power pins that are available. Certainly on those dev boards, you'll find that one of those pins that plugs into the breadboard will be a 3-volt, and there'll be a ground or a number of grounds as well. If you obviously, just be careful of the voltage. Some of the pins will only take particular.
Because presumably you can use GPIO and put them. It depends what you're trying to do, but you could put them into opto isolators to switch higher voltage devices. I mean, that would be my instinct.
Yeah. But you wouldn't want to power that from your computer. You'd want an external power supply.
No, but I mean, opto isolators are a nice way of buffering off of things.
Inactivity alarm.
And oh, hello. I can hear something.
Sorry, it's my robot.
It's feeling that you're not being very.
I'm not paying it enough attention.
But what I think what Brian was trying to get at, he's been trying to find this sort of information out, and he can't find it easily online. Is there a particular website where you can go to find out information about Arduinos?
So Arduino.cc, I think, is the actual Arduino site itself. But you might find Adafruit easier. They will have Arduino clones, and a lot of their feather boards. They have. So the feather board is a much smaller version of the Arduino in a particular form factor. They produce a number of different feather boards with different processors and different capabilities. So once you know what it is you're trying to do, you could probably pick a feather board which is appropriate, and you'll be able to see, from their site how to hook it up to power, how to program it, and those things. They provide very, very good guides.
Okay. In fact, I've just seen that Graham Cowan has just actually sent a message to Brian specifying the same website you've just given. So thank you very much, Steve, Graham, for that. Now just follows on. Pete has asked the question: do you know of a good set of online tutorials to get started with GPIO programming and all projects on a Pi or Arduino, etc.?
Again, I'm sort of going to refer you back to the same sort of place. If you're starting out, you can do worse than go to Arduino or Adafruit, I would suggest. Arduino is probably a little bit behind now from an education perspective. Adafruit are definitely focusing on education and getting people into using the microprocessor microcontrollers, and they've got some really, really good tutorials that start you from nothing, really. Okay,
well, what we'll do is perhaps when I send you across the questions, perhaps you could just answer and give the link, so anybody who wants to follow through can look, because I know it's quite difficult when you're hearing it spoken to start writing down on the website. Certainly, I did buy a Raspberry Pi just to play with, nothing at all complicated. It was just within an educational environment, and I found the dummy guide was quite good on the Raspberry Pi. Giving you some little projects to try using a Raspberry Pi on, and explaining a GPIO. I know that's a Raspberry Pi book, but Dummy's Guide is quite good on that. Yeah, sorry, I tended to focus on the microcontrollers. Oh, yeah, sorry, I appreciate. Yeah, if somebody wanted to play with a Raspberry Pi, then buy yourself the yellow Dummy's Guide. It's I found it quite helpful.
And again, the Raspberry Pi Foundation, they're set up as an educational organisation, so they provide a lot of tutorials as well. So if you start on their website, if you're working with the Raspberry Pi, then that's a good place. And also, Google is your friend.
Indeed, providing you ask the right question, I found it's a fantastic tool. But if you ask slightly the wrong question, you get some really quite interesting answers that don't always help you at all. Right, okay, I'm just looking down a list of questions here. Fortunately, we haven't got hundreds of them. I'm just trying to pick out any common themes. Adam has asked a question: what's the best way to maintain an accurate clock without an internet connection? Well, I suppose it begs the question, do you need to maintain an accurate clock? And if yes, how do you do it without an internet connection?
Okay, so there are things called real-time clock chips, whose sole purpose it is to keep good time. I mean, it obviously good depends on your definition, but good enough time. The real-time clock has a 32 kilohertz crystal. I might be 1,000 out with that one. It's got a 32 point something crystal. And that is used specifically to keep wall time, as in what time of day it is, what the calendar is. So if that was the question, real-time clock chip, and some of these boards have things built in. The ESP32 itself has a real-time clock chip inside it.
Right. I suppose actually, I was always expecting the answer that you have a plug-in board that actually is using GPS time. Yeah,
that's probably a bit expensive solution, but
that
would do it.
Some of those GPS solutions are actually getting very cheap now. I believe and the clocks are obviously got to be pretty accurate. But I agree, it does depend on the level of accuracy you need in the clocking environment. Okay, I'm just looking down to see what else. Oh right, okay. Again, Adam's asked the question: where do you get your boards made? I'm not sure exactly which boards he's talking about, but
he means the PCBs. So I tended to buy them from China. There are a couple of board houses which it says PCBWay is one of them, and JLPCB is another. I've generally found them to be good, and they're certainly cheap. You would probably get higher quality from, I can't think of the name. Osh Park, which is, I think, an American PCB house. Again, it's a trade-off. It'll cost you slightly more money. The boards are probably have a slightly higher quality control threshold on them. Sorry, one thing I didn't mention when I was talking about the PCBs is actually that the Chinese firms, or a number of the Chinese firms, will even populate the boards for you for small batch runs. Now we're talking, small batch being 50 to 100, which is not hobbyist stuff. But there was a question earlier about, if I made this, can I sell it? There may be people that are interested in getting small batches made. The only thing I would say is be a bit careful, because quite a lot, the availability of the components tends to be in and out, and you might produce your first batch, sell them all and be a success, and then try and produce them again. And unfortunately, you can't get the parts. So just be aware.
Okay, thank you very much indeed. I've a gentleman called Captain Bird's Nest has just replied saying it's probably a 32,768 hertz oscillator.
32K, yeah. Okay,
divided by 2 to the power 15 gives you 1 hertz. I'm not going to sit and do the maths. Thank you, Captain Bird's Nest. I'm assuming you've done your maths correctly there. And somebody else, Christoph, Baru says regarding a clock, he is suggesting using a GPS shield. I personally don't know what a GPS shield is, but I assume it's the sort of idea that you have a plug-in board, which is
yeah. I mean, again, it depends on what your requirements are. So if you want very high accuracy, GPS is the way to go. But you're balancing power, price, and everything in your design. So yeah, just depends on your application really.
Okay. Something just interesting. John Barker asked a question. He wants to convert analog audio into the digital domain, process it and convert it back to audio. Would you recommend Raspberry or Arduino for that sort of application?
What are you doing with it when you've got it in the digital domain is the question.
I don't know. I have no more information on it than that. I was just.
I would probably say Pi. Pi's got more processing power. So if you're DSPing it or something around that, then I would say you've probably got more legs in the Pi to allow.
Keegan, you were waving your hand.
Yeah, so I'm a bit of a musician myself as well, so I've not done this directly, but I've got some knowledge of it. There's something in and out sounds a bit like a guitar effects pedal, and I know that both on the Arduino and the Teensy especially, that's used a lot for audio processing. But there are specific audio interface hats you can get for the Raspberry Pi, and they're absolutely fantastic. I've seen people make virtual, as in software-defined multi-guitar effects pedals for those, and they do real-time processing for the audio. So I'd say that's possibly a good place to look. So sorry for interrupting. It's just something I know I've seen, and it's quite obscure. So
yeah, it's not something I've done. So thanks, Keegan.
Okay, thank you very much indeed. Yeah, it sounded an intriguing application. It just caught my eye, having worked in the broadcast industry in audio. I caught my eye something about trying to build your own digital effects processor. It just sounded intriguing. No. Yes. Okay. There's been one or two questions following on about the power requirements. I'm not going to put them specifically, but I'll try to summate them. Gordon Brown has pointed out that the Arduino Uno has an onboard voltage regulator, and you can power it. He recommends, says it can up to 12 volts from, I think he means a wall power pack, a typical pack you can buy and plug into the 13 amp power point. Yeah, I noticed here he says, in theory, the Arduino Uno can go up to 20 volts, but not recommended, he said. So that sounds intriguing. That sounds like he's tried it. And there's sort of there's been a little haze of smoke. But he's just saying that, you've got the onboard regulator so that you can, you don't have to necessarily find a 5 or 3 volt power supply. And somebody's just, Paul has commented that he's been using a BBC microbit, which does work, is a 3.3 volt onboard system to control some high power DC actuators. And just notes the in-out is quite low power. Well, I'm not surprised. I mean, I've used the microbit, and it's a very nice, effective little chip, but it certainly only claims to sort of drive a typical LED, about 10 milliamps, I seem to remember, is I think what they recommend. So I'm not surprised if you're trying to drive big actuators, you need to do something. I have used a microbit in an application where I needed to drive something, and I just used the output to put into an opto isolator, and then use the output of the isolator to turn on a much more bulky power supply. I just assumed that LED currents was all you were going to be able to use the microbit for. So I've not tried it with anything more substantial, but my gut feel is I wouldn't try to use a microbit to feed anything gutty.
Well, these sorry, you can't really see it, but inside the sorry, I can't. No, there we go.
Yeah, I can see it. Yep.
Yeah. So obviously the battery's there, and that can source quite a high current. But I'm using FETs or H-bridge drivers to drive the motors. So again, large currents actually driving the motors, but the interface to the microprocessor is very, very low current.
Right. Okay. I think we'll come to the end of the Q&A now in a moment. I was just reading somebody who's just saying that just he felt that the talk wasn't quite as advertised, and I apologise to that person, because the publicity material I do, and if I misrepresented it, I apologise. That Advance is, in answer to this particular person, Advance, you're doing this voluntarily. You weren't press ganged into this. You're doing it under your own auspices, and neither is the IET pushing this. So publicity material is entirely down to me, and I apologise if I sort of put the emphasis, misrepresented the emphasis on that. Okay, if unless anybody's got any other burning questions they want to ask, let's say all these questions will be collated, and Vance will look through them and see if he can come up with some common grouping or some answers, which will then be posted on the IET website, and also the video. I did respond to somebody who asked the question about where they could find this. I did send it out to everybody, and this was about half an hour ago, and I gave the website link to IET Bucks. But if you just Google IET Bucks or IET Buckinghamshire homepage, it will take you through to the page. I think, if I remember correctly, the video and the Q&A, the questions, they are available. Everybody, you don't have to be an IET member to get them. I think they're on the public page, but just Google it and it will take you through to the right page. So that's IET Buckinghamshire homepage, or IET Buckinghamshire events. Mr. Google's really good on that. It will take about a week before the video is posted. So if you go there tomorrow, you definitely won't find it. But it will come out in about a week's time. I'm not sure what happens to the video, but it obviously goes off for some special, I don't know, doctoring or something, and eventually it emerges. I get an email saying it's now posted, and I'm afraid it's just a matter of just keep looking for the video coming up. But I would try in a week's time. I'd like to thank my colleague Brendan Hampshire, who's to live in Buckinghamshire, and contacted Vance and Keegan, who moved because we were going to have your talks last year, just about the time we got the first of the lockdowns. It was going to be there, and Brendan found both you gentlemen to give your talks. I'm very grateful, because it was a very interesting talk this evening, and I'm looking forward to Keegan talking about the applications within the robots and the robot war environment, and see how you can use some of the technology you've spoken about, Vance. So Brendan, if you're still on the call, thank you very much indeed. Excellent. We are missing you in Buckinghamshire. But if you have any brilliant ideas where you are now living, please give them to us rather than the local branch, okay? So just a final mention, the survey that's being done by the IET communities, just to find out your views about how well IT communities are meeting your needs as a member. So if you want to take part in that survey, I've posted the link, or if you don't pick it up from there, just drop me an email. My email is available on the publicity for any of these events, and also on the IET Bucks homepage. And I very welcome any emails, as long as they're not too rude, and I will respond to them. Vance, thank you very much indeed for giving your time and giving a very interesting talk about the use of the Arduino and similar technology within the home hobby environment, particularly looking towards quite complex beasts there. I believe, I seem to remember somebody a few years ago talked about using similar devices to build their own 3D printer, but I wouldn't. I think that's probably quite an interesting concept, to building your own 3D printer, but it can be done. I remember this chap coming along and sort of dumping this unit on the bench and firing it up and printing something off. And I've got a feeling he was using something like an Arduino to drive the extruder head and so on. Right, so thank you very much indeed. Are there any last words you'd like to give, Vance?
No, just thanks everybody for attending. I'm sorry if it was a bit too in depth for people.
Well,
you know,
sorry, carry on.
It's difficult to pitch. You know, I'm just trying to share, you know, what I do, and hopefully it's relevant for you know, some of the people that were on the call.
Well, as far as I'm concerned, I found it. You know, I found it right, and we've had a comment. Thanks, Vince. Oh, I actually said Vince, but Vance. Thanks, Vance. A very interesting introduction to you know, these sort of more complex chips, and they are available. You know, they are usable. They're not something for use within you know, companies who are doing research or complex things. They can be used for sort of quite normal tasks, can't they? And
can be used for watering the plants or
yeah,
whatever.
indeed.
You know, we've got a variety of people in the from the hack space, you know, get involved in projects as simple as that.
Yeah.
You know.
Yes, that's right. Yeah, I mean, you know, if you want something to be automated, these are ideal tools with, and certainly the Raspberry Pi with it, it's got a lot of GPIO capabilities. So if you're looking to control a lot of different functions, then it's certainly there. If you're only looking to control 3 or 4 things, then think about getting a BBC microbit, because there I'm not a Python user, but the Scratch programming that the BBC microbit uses, even I can cope with Scratch programming, and that's pretty nice. And it's got quite a nice online tool to help you fault find and get rid of the bugs. Okay, well, thanks everybody for being on the call, and it's now time to say good night, and have a nice rest of the evening. Thank you and goodbye.